Welcome back to episode 2 of the MLOps series. In episode 1, I told you the real story of how an ML model failed in production and dragged me straight into MLOps. Today, we are going to recreate that entire mistake. Yes, we are going to build a model that works beautifully in our notebook but breaks instantly when real users touch it. This is exactly how real companies get into trouble. Real companies get into trouble. This episode will open your eyes. And quick reminder before we start, this series is not about learning deep ML maths. We are not becoming data scientists here. We are ML ops engineers. I wanted to make it very clear about this. So, we care about workflows, we care about pipelines, we care about tracking, reproducibility, monitoring, failures, and deployments. So, don't expect heavy ML theory. This is real engineering. Now let's jump into the demo. I'm jumping into my Visual Studio Code. Here I have MLOps episode 2 folder. Inside this particular folder, there are two folders. One is data folder and the second one is model folder. And inside model folder, I have three different files which I'm going to explain in a moment. Before doing that, first of all, I would like to create a virtual environment. So for that, I'm going to use Python 3 space hyphen m venv space dot venv. So we are trying to create a virtual environment so that I don't want to install packages globally. So we have a .venv folder created and I'm going to activate that. Source dot virtual environment bin activate. So right now we are out of the virtual environment. After activating, we are going to get into the virtual environment. So I can install anything here. So I would like to do a pip upgrade first before installing anything. So I'm going to say pip install hyphen hyphen upgrade pip, press enter. Requirements already satisfied, so that's fine. Followed by I'm going to install some packages which are required for our demo. So I'm going to install scikit-learn, pandas, MLflow. That's it. We are not installing TensorFlow, PyTorch, Transformer, nothing heavy. This is MLOps. Even simple models can create real problems. Press enter. This will take some time. I'm going to fast forward this. So most likely it should work. Okay, this is done successfully. Now let's talk about our model directory generate data.py. This is a very simple script that creates a messy data set exactly how real customers complain. We'll have some text, some emojis, some spelling mistakes, short messages, weird phrasing. This simulates real world messiness. Now we are going to run this by using Python space model generate data.py. So as soon as we generate, it will try to save it in a data.csv file in data folder, which I have it here. So I'm going to run this real quick. Press enter. You see, we have data.csv saved. We have data.csv created. This is our training set, tiny but realistic. Okay. Now let's train our first broken model, tiny but realistic. Now let's try to train our first ML model. This is the exact situation in most companies. Small data set, quick model, excitement. Let me explain this script on a very high level. First, we are going to import pandas, MLflow, pickle, basic stuff. We also add a small patch here. If you see, we are trying to add a small patch to prevent MLflow's copy stat crash on Windows WSL. So because I'm using Windows here, purely technical, nothing to do with ML at all. If you are using Ubuntu directly, you are not going Ubuntu or Mac, you are not going to add all this stuff. I'm doing it because I'm using Windows and WSL stuff here. First, we are going to load messy complaints, the data.csv which we generated here with a text and a label. Followed by we are converting bag of words, counts words, very simple, perfect for demos. Then we are trying to train model, no rocket science. This is just a basic classifier. Followed by we are trying to evaluate the accuracy. Here's where excitement begins. The accuracy looks good, 92%, 88%, whatever, some number. This is exactly where ML teams go deploy and everything breaks. Now we track the MLflow run and log metrics. This is important. At least we have a record. Followed by we are going to save the model and vectorizer manually. This is important because in episode 3 we will break everything by not using these correctly. This is a real world MLOps mistake. So this model is supposed to be bad. All right. Now let's try to run the script. Python space model train v1.py. Press enter. As soon as we run, we should see something like a baseline accuracy. You see, baseline accuracy 1.0. And this is the trap. This is where teams think, bro, 90% accuracy, let's deploy this, and everything collapse later. I would like to show you another thing. Let me run a simple command, MLflow UI port 5000, and try to show something in the browser as well. Press enter. Now I can copy this URL and open in browser. So let me bring that here. So I try to open MLflow in the browser. Here if you see, this is our run, baseline text classifier, and also the run name we can see, the source also we can see, and we will have our artifacts as well. So model metrics, system metrics, model metrics, you see the accuracy, system metrics, artifacts. So model.pk, vectorizer.pkl. Bare minimum, but better than files in downloads. Now let's see how this model behaves with real messages. So I'm going to jump back to my Visual Studio Code. I'm going to stop this. I'm using another terminal and I'm keeping this open. Now let's see how this model behaves with real messages, not the Q training messages. For that, I'm going to run Python 3 space model infer v1.py. Press enter. Now if you see, we have different groups here. For example, training like text, unseen real world noisy text. So, group 1 messages, if you see, these are similar to the training data. Of course, the model does well here. It has seen patterns before. So, for example, network not working properly, predicted, network, confidence is good. Wi Fi dead, predicted, network, confidence is good. Fixed network, predicted. So, you see, it works fine. Whereas, now real world messages. Internet dies every night after 11 p.m. Predicted network. Confidence is 0.63. Balance cut but recharge not working, bro. Predicted network. Confidence 0.59. Wi-Fi works on phone but not on laptop. Predicted billing. You see the difference? Real world messages and the trained text. Some predictions are wrong, some are right but shaky. Some have very low confidence, for example 0.53 here. This is the model telling you I'm guessing, don't trust me. And this is the exact blind spot that destroys ML deployments. Let's do a quick summary of today's episode. Let me summarize exactly what we did today. We created a tiny, messy dataset, trained a basic model, okay, logged it with MLflow, then saved the vectorizer manually, followed by tested on real world messages. And was the model struggle? And this is where MLOps begin. You don't need deep ML knowledge. You just need to understand how model behaves, what they depend on, where they fail, and how to track them, and most importantly, how to fix them. So, in episode 3, we are going to take this messy model, put it behind a fast API service, Dockerize it, and send real HTTP request. You'll see exactly how a model that worked in my notebook becomes a headache in production. Then from episode 4, we'll start building the real MLOps pipeline. If you like this video, comment, break it, and subscribe because this series is just getting started. See you in episode 3.